Hi everyone, it's Mrs. Brimlow, and today I'd like to formalize what we know about systems of equations by graphing. So we've done two different investigations, and now we're going to kind of bring it all together in these notes. So this is page 11 of your notes. If you don't have the notes yet, they are linked in Canvas. So systems of equations graphing. So systems of equations are a set of two or more equations with the same variables. The solution for a system of equations is an ordered pair that makes both equations true. The point is often called the point of intersection. Note, the solution to a system of equations must lie on the graph of both equations. So it means if I was to substitute that point into each equation, it would be a true statement. It's part of the function. The input and the output go together for both functions. Okay. So if we take a look at this graph and we wanted to know what the solution is, the solution would be right here where they intersect, and that point is 1, 3. Okay. So when we're writing our points, we always do x then y. So 1, 3 is that point of intersection. And through our investigations, we found that we have three different types of solutions. So I'm going to use a highlighter. You could just box if you wanted to. So if it's one solution, it's going to have different slope and different y-intercept, okay? And they're going to intersect at one point. So one solution, everything in the equation is going to look different. Okay? If I have a no solution, they're going to have the same slope, meaning they're moving at the same rate. However, they're starting or hitting at different places. They run parallel to one another. Therefore, they will never intersect. So they have no solution. So that means each of these equations has the same slope, which is why it has the same steepness, where it's moving at the same rate, but why they'll also never cross. Okay. Then we have what we call infinite solutions, and that's when we have the same slope and the same y-intercept. They end up being the same line. So remember, we can write equations many different ways, simplified, not simplified. We've been working with just slope-intercept form, but there are other forms that you could write an equation, and when you change them to be the same form, you'd see that they would be the same exact equation with the same slope, same y-intercept, okay? So on your graph, if you had infinite solutions, it would look like one line. You can see they try to overlap it, so they've got a smaller line over the larger line, but at the end of the day, it's the same line, okay? So if you could flip to the next page, we're going to go through the process of graphing and each solution and practice looking at a set of equations to guess what the solution type will be before we finish graphing. So using the graphing method, you want to make sure that they're in slope-intercept form. For our purposes, most of the time they will be. When you move into Algebra 1 next year and Math Beyond, they might not always, and you'll learn the skills you need to work with those. But make sure they are in true slope-intercept form, y equals mx plus b. So then you're going to graph the first function, and I would use at least 2 or 3 points, even more if you can fit them, just because the more accurate the line is, the more likely you are to find the point of intersection accurately. Graph the second function, same thing, and then you look for their point of intersection. And remember that if there is no point of intersection, you want to see if the lines are parallel or if they're the exact same line, because it could have those different solution types. Okay. So just looking at the equations, looking at the slope, right away they're different, okay? That means this is going to have one solution. So that means it should intersect at one place. This is a really good strategy to help you get comfortable just looking at equations, but also too, so that way when you get an answer, you can see if it makes sense. So just looking at the equations, I know they should only have one solution, so there should be a point of intersection when I graph this. So for this, the y-intercept is 6, so I'm going to start at 6. I have a negative slope, meaning I'm going down. Rise over run means I start with the 3. So I'm going to go down 1, 2, 3 over 1, 2, 3, 4. And I don't think I'm going to be able to fit another point on here, so I'm just going to leave it. Okay. Draw my line as best I can. Okay. All right. So for my next one, I'm starting at 1. I go up 1 over 2, up 1 over 2. So by putting multiple points, not just graphing the line, I was able to find the point of intersection. So then I graph this as best I can, extending my lines. So once again, we knew from the beginning this was one solution since they had a different slope. And I can see it's right here at 4, 3. So the solution to this is 4, 3. That point is on both of these graphs. Okay. All right, so next one. I have y equals 2x minus 3, and then I have 3y equals 6x minus 9. Now, even though this is y equals, there's a 3 in front of it, and it's being multiplied by the y. I need it to be just y equals. So the opposite of multiplying is to divide. However, I need to divide each term by 3 to keep it balanced. So this is y equals. So 6 divided by 3 is 2, and negative 9 divided by 3 is negative 3. So when I look at this equation and now this one, I can see they're the exact same. So this is infinite solutions, meaning it's just going to be one graph. So starting at negative 3, I'd go up 2 over 1, up 2 over 1, up 2 over 1. And this is infinite because they are the same, or all real numbers is another way to describe it, or all real solutions. You might see it that way. So we just need one line for the two because they're the same. All right, now our last one, they have the same slope, which could indicate they're infinite or no solution. However, they're starting in different places or hitting the y-axis at different places. So this is going to be no solution. They're going to look like parallel lines. So for this, I'm going to start at negative 1, and then I'm going to go down 1, 2, 3, 4 over 1. Okay. And then for this, I'm starting at 6, and I'm going to go down 1, 2, 3, 4 over 1. So they're going to be very close to each other, but they're not going to quite overlap. If they do, that would be an error on your part in terms of drawing, which happens. These hard lines can be tricky to draw, but you can see these don't overlap. And so this has no solution. So now you should be able to identify the types of solution by inspection of the graph or by inspection of the equations. And you should be able to graph a set of systems of equations. So you can go ahead and continue practicing either in your packet or whatever's been posted in Canvas. If you have any questions, please let me know, and